So please copy this down. This is a class opener / review for the quiz tomorrow. We're going to need to know how to fill in the blanks here. We need to know what a function is. Okay, so copy it down. I want to hit pause and then we'll go over it. So I would copy this whole thing in your notebook because this is exactly how it's going to be on the quiz, right? A blank is like a machine. We've had this on our notes. A function. For each blank, there's exactly one blank. For each what?
For each input.
For each input, there is exactly one output. And you guys should remember that, right? I said a function's like a machine. You plug in a number, you get out an answer. You plug in an input, you get out an output. You could also say you plug in a domain. If you wanted to, you could say you plug in a domain. But I would just say leave it as input, output. It's the most straightforward thing when it comes to defining what a function is. For each input, there's exactly one output. Let's continue reading here. If you ever plug in the same input and get out different outputs, then your machine must be broken. Therefore, it cannot be a function. It must be a relation. Okay, so the first part of our quiz is going to be fill in the blank, something similar to this, if not exactly. And then we're going to move on to comparing different graphs, different XY tables, input-output tables, and more. So right here, we're going to be determining, by the way, if you needed more time on the other part, just go back, watch the video, hit pause, copy it down. On this one, is this a function or is it just a relation? Okay, some people are saying function, some saying relation. Now, what we need to do is apply the vertical line test. So draw a vertical line, and here, this blue line is my vertical line. If it ever has more than one dot on it, does it have one dot right there or two?
One.
Just one, just one, just one, just one, just one, just one, just one. So it passes the vertical line test. It does pass the vertical line test. So this is definitely a machine that works. It's a function, right? Yeah. Well, I don't know if. How about this? You don't have to write it down, but just make sure you watch the video, okay? Because you guys need to study this tonight so you can get a good grade tomorrow. So the vertical line test works, and even if you didn't know the vertical line test, you could actually think of all the coordinates, right? You could think of the coordinates like this one is 0, 3. This one is 1, 2, 1, comma 2. This one is 2, 1. This one is this is 3, negative 1. This one is negative 0.5, comma 2. And this one right here is negative 1, comma 1. And this last one is negative 3, comma negative 2. Now, you don't have to do this. I'm just saying if you totally blank out about the vertical line test, you could look at the coordinates and then remember your x's are your inputs. So you plug in negative 3, you plug in negative 1, plug in negative half, plug in 0, plug in 1, 2, 3, and you never plug in the same input and get out different outputs, right? It would be a different story if you had another coordinate right here and that coordinate would have been 3, negative 2. Then the single input 3 gave you two different outputs, right? You plugged in a 3, you got out a negative 1. You plugged in a 3, got out a negative 2. Then the machine would be broken. And as you can see, if you did have both of these dots, it would fail the vertical line test, right? It would fail the vertical line test. But then again, that blue line that blue dot didn't exist, so it does pass the vertical line test. Let's move on to the next one, number 2. If you want to copy this down, you can, or you could just watch the video and review your homework. I think this is from the homework anyway. So is this a function or a relation?
Function.
Function, okay. How could we safely say it's a function? Because you never plug in the same number and get out two different answers, right? Plugged in a 4, got out something. Plugged in a negative 1, plugged in a 0, 1, 9. You never plugged in the same number twice. Now, if for some crazy reason you'd have another box down here, and you plugged in a negative 1 and got out a negative 11,
That's a relation.
then that would be a relation. Because if you plug in the same number twice and get out different answers, negative 1 gave you negative 10, negative 1 gave you negative 11, that machine's messed up, it's broken. So that would be a relation if that were the case. Now, what if this wasn't a negative 10? What if that was a A positive 10.
I still negative 10.
That's relation.
I mean, negative 10, sorry, negative 10.
A function.
So, yeah, if you did have a negative 1 and a negative 10 and a negative 1 and a negative 10, it would still be a function, right? Okay, let's go back to the original. Let's erase what I jotted down here. So the original absolutely is a function. Why? Because you never plug in the same input twice and get out different outputs. Let's move on to number 3 right here. Graph. Let's use a vertical line test. Is this a function or just a relation?
That's a function.
It's a function, right? Tell me when to stop. Right there. How many times does it touch the blue line? Once. Stop. One time, one time, one time, one time, one time. So, as you can see, this does pass the vertical line test, so it is a function. You with me? Now, it'd be a different story if I drew, let me draw something like this. Look. What if it were like that, if it were sideways?
Function.
Then that would no longer be a function, that would be a relation because it crosses twice, and that would fail the vertical line test, right? If you got your vertical line, it would cross it twice. Okay, but then again, on this original problem, it didn't cross twice. It was a parabola opening up, not sideways. So it is a function. Let's move on. Number 4. Oh yeah, here's one that's sideways. What do we say? What is this? This is definitely a relation. Put an R right there, relation. By the way, all functions are relations, but not all relations are functions. Anyway, take a look at this question right here, guys. State the range of number 1 above. What would you say the range is to number 1 right here? What is the range? We need to know this for the quiz tomorrow.
What do you mean?
What is the range? Now, if you're thinking, what the heck is range? That's something that you need to know.
Oh, it's 3.
The range is the what?
The height?
The heights, okay. The range is the not, but give me y, the y values. The domain is the x values. The range are the y values.
So 0, 3?
You need to know that. The domain are the x values. The range are the y values. And I will ask you both on tomorrow's quiz. So check it out. If I say state the range of this whole thing, state the range. I'm really saying state the y values. So what you're going to do is write down R, put a little colon, and then give all of the range values. What are the range values? The y values. What are the y values here? Well, you have negative 2 on this coordinate, 1 on this coordinate, 2 on this one, 3, 2, 1, negative 1. Okay, so we have, let me write it down. Negative 2 was the y, 1, 2, 3. Now, since we're on this one, it's 2 again, but we already have it. Oh, no, we don't. Yeah, we do. We already have it there. We don't have to write it again, right? And then this one's 1, but since we already have it there, we don't have to write it again. And this one's negative 1. I need to write that one because it's not there yet. Does that make sense? Simple question. You're not doing any math. All you're doing is checking out the y values. If I asked you, I might as well ask you for the domain. What are the domain values of this thing? Negative 3, negative 1,
Is that negative 0?
negative 0.5, or negative 1/2. 0, 1, 2,
Negative 3.
and 3. So none of them repeat, right? All the inputs, the domain are the inputs, the domain are the x values, negative 3, negative 1, negative 1/2, 0, 1, 2, 3. All the x values are the domain. So those are like free points. And that even happens on the final exam before Christmas. It's like a free point on the final. You just need to know, you need to remember that the domain is the x values, the range are the y values. The domain's the input, the y is the output. Okay, what if I asked you for the range on this xy table? What would you say? Negative 5, negative 10, negative 9, negative 7, 1. Okay, cool. All right, let's move on to the last part of the review. The last part of the review is actually function notation and evaluating them. So let's first start. I would write this down, guys, since you're able to. Start with this top part up here. F of x is 3x plus 2. And let me say this. There is a big difference between f of negative 2 and f of x minus 2, and also f parenthesis x minus 2. And we're going to go through all 3 different notations here. So let's go with the f of negative 2. Now, this notation is telling you to rewrite the f of x function, but instead of the x, let's write it with parentheses, okay? So instead of writing 3x, I'm going to go 3 parentheses, and then bring down the plus 2. And the question is, what am I actually going to plug into x? The negative 2 is what I plug into x. After all, over here it says f of x, and the x got replaced with the negative 2. That's a notation for saying, hey, replace your x's with negative 2 in there. Okay, so let's plug in a negative 2 in there. Let's work it out. 3 times negative 2 is negative 6. Bring down the plus 2. Negative 6 plus 2 is negative 4. That's as easy as it could get, right? We all know how to do that, yeah? Okay, now let's compare it with this guy over here. What does this say? It says f of x minus 2. Am I supposed to plug in anything for x? It's the same exact thing, right?
Yeah.
So you see how it says f of x is this? Well, let's just write that in place of f of x.
3x.
Yeah, so let's write it out. This 3x plus 2, let's write it out. 3x plus 2. And then we have this minus 2 at the end, so put minus 2. And what's our final answer going to be? If you simplify, just 3x. Why is that? Because the plus 2 and the minus 2 become 0. So sometimes they'll write the function notation with a number. That's really easy. You just plug in the number. Now, if they just say f of x, you're not doing anything with it. You're just keeping it exactly the way it is. So you just keep it exactly the way it is. And then at the end, it has a minus 2. So subtract 2 at the end. Let's look at this third option over here, or the third notation. What's it telling us to do? First of all, we're going to be using the f of x function. So let's plug in parentheses instead of x's. Replace the x's with parentheses. We're going to have 3x plus 2. Now, what belongs inside that parenthesis? What belongs inside that parenthesis? X minus 2, right? Normally, we have a single number in there, like right here, negative 2. You plug in negative 2, right? Right here, you have x minus 2, so let's plug in x minus 2. X minus 2. And after that, you simplify. And what do we really have here? We have distributive property and combining like terms, okay? So 3 times x, 3x. 3 times negative 2, negative 6. Bring down the plus 2. Combine like terms, negative 6 and positive 2 is negative 4. Bring down the 3x. 3x minus 4 is your final answer right there. So I just wanted to clarify the different notations and what they mean. So I want you guys to practice now. Let's take a look at these two functions. We have r of x and p of x. So it depends which one you need to use. I want to pause it. Go ahead and do number 1. Let me explain this one more time. Guys, you see this r of x and you see this p of x? It's just the name, right? It's like calling this guy Sergio and calling this guy Paco. I don't know, whatever. But the r of x and the p of x are just names. Now, why do we want names? Because this r tells you to use this one. This p tells you to use this one.
So then you put the 2 and then you try to put the other 2 minus the 6, right?
Yes, exactly. So once again, the r, what this is saying is go to your r function, plug in 2 for x, right? So let's do that. Let's go to our r function. Here's our r function. Let's rewrite it, but instead of x, let's put parentheses. 2 parenthesis minus 6. And now we plug in the x value of 2. That's what this says up here. It says go to your r function and plug in 2. Work it out. 2 times 2 is 4. 4 minus 6 is negative 2. I hope everybody got that. You need to do this on the quiz tomorrow. P of negative 1. This tells you to do something. This doesn't mean something. I mean, it tells you to do something. You go to your P and you plug in negative 1 for x. So let's go to our P and let's first replace the x's with parentheses. So instead of x minus 2x squared, I want to go x minus 2x squared. And now what am I actually plugging in? The negative 1. Put the negative 1 right there and negative 1 right there. It's very important that you use parentheses. That way you don't make mistakes. So we now need to go to Pemdas. Parentheses, there's nothing to do inside these parentheses. There are regular numbers in there. We go to exponents. negative 1 squared. Negative 1 times negative 1 is positive 1. And I'm going to bring down the multiplication, the 2, the minus, and the negative 1 doesn't even need to be in parentheses anymore. So what do I do next? Subtract or multiply? Multiply first. So when I multiply negative 2 times 1, that's still negative 2. Bring down minus 1. And now we could actually combine those terms and we'll get negative 3 as our answer. You get it? Number 3, we're using R. It says use the R function, plug in 7, and then what else does it say? Subtract 11. So we're going to go to the R function, we're going to plug in 7, we're going to get an answer, and then we're going to subtract 11. Okay? So the R function's right here. It says 2x minus 6. I'm going to write 2 parentheses minus 6. Okay? And I'm going to plug in what? 7. Okay, so let's work this out. 2 times 7 is 14. 14 minus 6 is 8, correct? And now, what else do we have out here? We have a minus 11. Let me bring that minus 11 right there on our answer. Subtract 11. And yes, your final answer will be negative 3. Let's try the last one. This one's a beast. We're going to use the P or the R function? The P. Here's the P. It says x minus 2x squared. What am I supposed to plug in place of x? A B. Don't let that confuse you. It's even easier because you're not even going to be doing any math. You're just going to take that B and plug it into the x positions. So I would rewrite it again with parentheses. Instead of x minus 2x squared, I write parentheses minus 2 parentheses squared. And then I plug in my B value right in there. So B right there, B right there. Okay? So far, I'm going to be working on the P of B. And all you could do here is nothing. You can't do anything. So you would just leave it B minus 2B squared. Yay? Now that's still inside the brackets. So what else do we have inside the bracket? We have a plus 3. So bring down the plus 3. And remember, this is still inside the bracket. Okay? And let's not forget about the 2 that's out here in the front. So inside the bracket, could I add any of these? No. They're all unlike terms. None of them are like. If this were a regular B, yeah, I could do B take away 2B. But that's B take away 2B squared. That's like a banana and then a banana squared. You can't subtract them. And you can't really add 3 to any of these guys because they're not alike. But we move on to the 2 on the outside and distribute that 2 to each of those terms. So 2 times B is 2B. 2 times negative 2B is negative 4B squared. And 2 times 3 is 6. And that's your final answer. I would like you to write the highest exponent term first. And then the rest, the positive 2B and then the plus 6 at the very end. It's just this is called standard form on your answer. Having the highest exponent term first, all the way down to your constant at the very end. So if you understand this video, you're going to be ready to ace this test tomorrow. If you're still feeling a little weird about it, I would go back and watch this video again. Wait, I said test. It's a quiz. It's not a test.